EES, which is pronounced EASE, is an acronym for Engineering Equation Solver. In the last few videos we talked about arrays in EASE and how to enter them from the equations window or also by using the arrays editor. In this video we're going to introduce the duplicate statement, which provides a convenient method for carrying out similar operations on multiple elements of an array. The duplicate statement is absolutely essential if you're going to be setting up numerical models using EASE. The protocol for a duplicate statement is shown here. The variable index is iterated from the value start to the value stop, and the equations then contained between the duplicate and the end statements are written for each iteration. So for example, this EASE code here is exactly equivalent to writing the 4 individual statements below, in which I takes on values from 1 to 4. When you're using duplicate statements, it's really important that you remember that EASE is an equation solver and not a programming language. So don't accidentally place equations within a duplicate statement unless you want them to be actually duplicated in the equations window. A common mistake that some users of EASE might make is shown here. So this looks okay, but it's actually exactly equal to writing the EASE code that's shown here. And what you can see is that the equation x equals 4 has been written for every one of the iterations of the duplicate loop, and that leads to 4 equations here, x equals 4. And of course, the end result of this is that you have 8 equations, but you only have 5 unknowns, and when you try to solve these, is going to give you an error message. You can use nested duplicate statements in order to generate two-dimensional arrays. So for example, the code shown here is going to lead to this two-dimensional array. When you're using duplicate statements, it's easy to make very big arrays, and so that sort of naturally leads into the next topic in this video, which is the Purge Unused Variables option. So EASE saves every variable that you introduce as you develop your program. So here's an example. This is a program that simulates a heat pump. One of the inputs here is ambient temperature. I can set the ambient temperature to 0 degrees Celsius and run the problem, and I'll get a solution. I might want to create a plot that shows the performance as a function of ambient temperature, and so what I'm going to do naturally then is comment out this variable T_ambient and run this parametric table instead and generate a plot. But later on I might want to bring that variable T_ambient back and use it to run a simulation, and you'll notice that when I do that, EASE remembers the units and any other characteristics that I've set for this variable T_ambient. I don't have to reset them, and that's why this is done. I don't want to have to enter all the characteristics of a variable if I just want to temporarily remove it for parametric studies or optimizations. However, if at some point you have an array that has 5,000 entries and later you reduce its size to only 500 entries, you have to remember that EASE is going to retain in memory the original 5,000 variables. It's not going to purge any of them even as you've resized the array. So 4,500 of these variables aren't being used. And this really becomes an issue when you're working with arrays. It's often the case that you're going to want to redefine the size of an array that you use in an EASE program. So for example, arrays are really useful when you solve systems of algebraic equations that result from numerical models. These equations correspond to a set of equations written for every node or control volume defined within some computational domain. And here's an example. This is a plane wall experiencing volumetric thermal energy generation. And here's the system of nodes that I'm going to use to simulate the problem. And this is the EASE program that I'm going to use. And you can see in this EASE program, I can set the number of nodes to some arbitrary integer value. And then this duplicate statement takes care of implementing however many energy balances I need. Now, one of the most important things that I might want to do with this model is verify that the number of nodes is sufficiently large that the model itself has converged. So here I'm accomplishing this check by increasing the number of nodes, and every time I do that I can observe how the solution changes. In this case, I'm just looking at what the maximum temperature in the wall is, and you can see it converges to some value if I make a plot. And the number of nodes that I want to use is always going to be a compromise between computational time and accuracy. So at the end of this process of looking at how many nodes I need, I've probably set the number of nodes to some really large value like 2,000. But once I'm done with that, I'm going to reset the number of nodes to something more reasonable, like 100, and now I can solve. But I have to keep in my mind the fact that because at one point I had 2,000 nodes, and now I only have 100, there's something like 1,900 unused variables in this ease program that will always be in memory. If I'd like to purge those variables, then what I need to do is select Purge Unused Variables from the Options menu. And here it's going to show you that yes, there are unused variables, and you'll have to confirm that you want to purge them. And when I do this now, those unused variables are gone, and my ease program has become much smaller. And in a lot of cases, that's kind of an important thing. So this is one of a series of tutorials meant to describe the operation of the ease software. If you'd like to get more information about ease, obtain the software, or access more of these tutorials, please go to the website fchart.com. These tutorials are excerpted from the book Mastering Ease, which can also be obtained from the fchart website.